Good afternoon, dear my dear students. So I hope that all of you are fine and safe at your home. Today let us discuss about structure of atom. Dear students, already as you know that what do you mean by an atom? Atom is an smallest particle. So means that it is cannot be divisible. The atom is a smallest indivisible particle is called an atom. So you can also write the definition for this atom. What do you mean by atom? Atom is a smallest indivisible particle is called an atom. So atom can be represented generally, and any elements can be represented in the form of, it is an x is nothing but any element that can be represented by, this is an atomic number, this is an atomic mass. It is nothing but an element or atom, here subscript this z is nothing but atomic number. So atomic number can be represented in terms of z, and here a is the atomic mass. Atomic mass can be represented in terms of a. So now let us consider one example for such elements or atom, the carbon. Carbon is an atom or element if it is consisting of atomic number, that is 6 is the atomic number. Here z is what? Atomic number. A is what? Atomic mass. Atomic mass is 12 for this carbon atom. So this is an element which consisting of atomic number 6 and atomic mass 12. Then any atom which consisting of its own atomic number and also as well as its atomic mass. Then how do you define the term atomic number and atomic mass? So what do you mean by atomic number? So let us define atomic number. So how do you define the term atomic number? Atomic number is defined as the atom which consisting of number of protons is called an atomic number. So what do you mean by atomic number? An atom which consisting of number of protons. The number of protons containing in a nucleus is called an atomic number anta helತೀವಿ. The number of atoms or protons present in a nucleus is called an atomic number. So atomic number is defined as the number of the atom which consisting of number of protons present in a nucleus is called an atomic number. So this is an element. So in this, which is the atomic number? The number of protons. The number of protons means 6 is the atomic number. The number of protons is always equal to number of electrons. Here we can say that the number of protons is always equal to number of electrons. The number of protons is always equal to number of electrons. ಹಾಗಿದ್ರೆ ಇಲ್ಲಿ number of protons ಎಷ್ಟಿದಾವೆ? The atomic number is itself is the number of protons. The atomic number is itself is the number of protons. The number of protons is always equal to the number of electrons ಅಂತ ಹೇಳ್ಬೋದು. So dear students, this is about the definition for atomic number. Then next one is atomic mass. What do you mean by atomic mass? Here in atomic number we have considered only the number of protons present in a nucleus is called atomic number. What do you mean by atomic mass? Atomic mass. So the atom which consisting of number of protons and number of neutrons in a nucleus of an atom is called atomic mass. So dear students, now you can define the term atomic mass. What do you mean by atomic mass? The number of the atom which consisting of number of protons and number of neutrons in a nucleus of an atom is called an atomic mass. So here you are observing that the atomic mass can be represented in terms of capital A. Capital A is the atomic mass. Means that what? It is the sum of number of protons and number of neutrons. Sum of protons and neutrons. Shortly also we can say that the sum of protons and neutrons present in a nucleus is called as atomic mass. So sum of protons and neutrons are nothing but this is n proton. So neutron, how do you calculate the neutrons? So neutrons can be calculated as follows. That is, the number of neutrons can be calculated as, so here neutrons is equal to A minus Z. Neutrons is equal to A minus Z. N is nothing but neutrons. A is nothing but atomic mass. Z is nothing but atomic number. So atomic mass, it is a difference of the atomic mass to the atomic number is called neutrons. So neutrons can be determined as, what are the number of neutrons present in this carbon? Carbon alli ಎಷ್ಟು neutrons idave? So atomic mass is 12, atomic number is 6, that is equal to 6. The number of neutrons is equal to 6. So in carbon the number of neutrons is equal to 6. So for example, one more example. So if I consider nitrogen atomic number is 7, atomic mass is 14. So what are the number of neutrons present in this nitrogen? So nitrogen alli number of neutrons estide antandre A minus Z, that is nothing but neutron. A is equal to what? N is equal to A is nothing but what? A is 14. Already I shown here. A is atomic mass. Atomic mass is 14 minus atomic number. Atomic number is 7. So 7. N is equal to how much? 7 only. So the number of neutrons present in nitrogen is 7 only. So this is about the number of neutrons calculation present in an atom. So structure of an atom. In the structure of an atom, we can able to consider the subatomic particles in the element atom. So what are the subatomic particles? So how can you say that the atom consisting of subatomic particles? So now let us take subatomic particles present in an element. So what are the subatomic particles in an atom? So atom consisting of subatomic particles. What are the subatomic particles of atom? What are the subatomic particles of an atom? It consisting of 3 subatomic particles. One is electron, second one is proton, third one is neutron. So these 3 are the subatomic parts of an atom, subatomic particles of an atom. So atom, it looks like, so this is a nucleus, this is an orbit, this is another orbit, this is another orbit, this is another orbit, this is another orbit. So this is a nucleus, this is a nucleus. So nucleus consisting of number of protons and number of neutrons, and the number of electrons which are revolving around the orbit, around the nucleus in an orbit. Here the number of electrons are revolving around the nucleus in a respected orbit. This is n is equal to 1, this is n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. So these are the energy levels. This is the energy level 1, energy level 2, energy level 3, energy level 4, energy level 5, etc., etc., etc. 6, 7, 8 energy level can be increased. This is an structure of an atom. Atom consisting of a nucleus. That nucleus consisting of a number of protons and neutrons is called as nucleons anta kariತೀವಿ. What do you mean by nucleons? Nucleons is the sum of protons and neutrons present in a nucleus is called nucleons. So here the number of orbits are the circular path which are revolving around the nucleus. Those orbits carrying electrons, those electrons are revolving around the nucleus, and these electrons are held in a orbit with the help of electrostatic force of attraction between this nucleus and electron. In this nucleus there is a presence of proton, that is positively charged electron, positively charged species. These electrons are negatively charged species. So positive charge and negative charge which are held together with the help of electrostatic force of attraction in a circular path. Those electrons are revolving around the nucleus, and there will be the neutralization of atom can takes place. Okay, here the subatomic particles are electron, proton and a neutron. Dear students, now let us consider about the properties of an particles, subatomic particles. What is the properties of an atom, or what are the properties of subatomic particles? So properties of subatomic particles, let us discuss now. Stop. Now let us consider the properties of fundamental particles. So which are the properties of fundamental particles? Means fundamental particles have the subatomic particles, the atom, the subatomic particles have electron, proton and neutron are the fundamental particles of an atom. So subatomic particles of an atom anta helತೀವಿ. So now let us consider some properties of fundamental particles. Properties of fundamental particles have electron, proton, neutron. Hagidre let us consider the name of the fundamental particle, that is electron. That is electron. Second one is proton. Third one is neutron. So these are the fundamental particles of an atom. Now what is the symbol for the fundamental particle of an atom, that is element, that is electron? The electron is represented by E minus. The symbolical representation for the electron is E minus. Proton can be represented by P. The neutron can be represented by N. So this is neutron, proton, electron. And absolute charge. What is the absolute charge of an electron? The absolute charge of an electron is 1.6022 into 10 to the power of minus 19 is the absolute charge of an electron. And absolute charge of an proton, absolute charge of proton is it is minus. Here plus 1.6022 into 10 to the power of minus 19. What is the absolute charge of an neutral? So neutron is having 0. 0 is the absolute charge of this neutron. And what is the relative charge? Relative charge of an electron is minus 1. So similarly the relative charge of an proton is plus 1. Similarly the relative charge of neutron is always 0. The relative charge of a neutron is always 0, and a discoverer. Who discovered the electron? The electron is discovered by J.J. Thomson. As you know that the electron is discovered by J.J. Thomson. J.J. Thomson, he told that an atom which is in the circular shape and which consisting of number of electrons inside the nucleus, he is called J.J. Thomson. First discoverer of an electron is J.J. Thomson. The second one is proton. Proton is discovered by an Goldstein. He who is the scientist who discovered the fundamental particle, that is called proton. And next one is neutron. The neutrons are discovered by James Chadwick. James Chadwick is the scientist who discovered the fundamental particle that is called as a neutron. So these are the three fundamental particles of an atom. The first fundamental particle is electron, second fundamental particle is proton, third fundamental particle is neutron. Its symbol is E minus, its symbol is P, its symbol is N. The absolute charge is minus 1.6022 10 to the power of minus 19, and proton absolute charge is plus 1.6022 10 to the power of 19, and neutron is charged. There is no charge for the neutron, and relative charges for the electron is minus 1, the relative charge for the proton is plus 1, and neutron is 0. And the mass in terms of kg, for electron is 9.10 in 10 to the power of minus 31 is the mass in terms of kg. So proton mass is 1.6726 into 10 to the power of minus 27 in terms of kg, and neutron is having 1.6749 into 10 to the power of minus 27 in terms of kg. And who discovered an electron? This question may ask for you in the point of examination. So who discovered an electron? Who discovered an proton? Who discovered the neutron? So the electrons are discovered by J.J. Thomson, protons are discovered by Goldstein, and neutrons are discovered by James Chadwick. So this is about the properties of fundamental particles. Stop now. So now let us discuss about isotopes. What are isotopes? Isotopes are the atoms with same atomic number, but different atomic mass, is called isotopes. So this is very important for the point of examination. For example, how can you show the example for this isotopes? Isotopes are the atoms with the same atomic number but a different atomic mass is called isotopes. An example for the isotopes is an element carbon, an element nitrogen. So isotopes, you can take one more example, that is hydrogen. 1 1 1. Here 1 2 3. So what do you mean by isotopes? Isotopes are the atoms with same atomic number. Isotopes are the atoms with same atomic number but a different mass number. This is the definition is called isotopes. So next let us go for isobars. What are isobars? Isobars are the atoms. Isobars are the atom with same mass number but different atomic number, is called isobar. For example, isobar can be defined as isobars are the atoms with the same mass number but different atomic number is called an isobars. An example for the isobar is carbon and nitrogen. Here carbon is having atomic number 6, nitrogen is having atomic number 7 and its mass is 14. Carbon atomic mass is 14. Here nitrogen atomic mass is 14. So here carbon is also in terms of isotopes ಅಲ್ಲಿ ಇದೆ, carbon isotopes ಅಲ್ಲಿ ಇದೆ. So second example for the isotope is carbon 6 12, carbon 6 13, carbon 6 14. So this is also an isotopes of carbon ಅಂತ ಹೇಳಬಹುದು. This is an isotopes of an hydrogen. Isotopes of an hydrogen is H11, H12, H13. It is protium, deuterium, tritium. It is also isotopes of carbon having same atomic number but different atomic mass is called as isotopes. Here the carbon is having isotope of C6 and C614. So this is an isotope. So it is an isotope. But when we consider the two different elements having different atomic number but same atomic mass, then such type of elements are called as isobars anta ಹೇಳ್ತೀವಿ. The isobars are the atoms with the same mass number. See here, the mass number is same 14, but different atomic number. See here, atomic number is 6, here atomic number is 7. That's why these kinds of elements are called as isobars anta ಹೇಳ್ತೀವಿ. So one more definition is there. So that is here isotones. So one more important definition, that is isotones. Isotones are the atom of different atoms can have same number of neutrons is called isotones. So what do you mean by isotones? Isotones are nothing but elements are having different number of elements having same number of neutrons is called as an isotones. So the example for that isotone is oxygen and nitrogen. So different elements having same number of neutrons, that is oxygen atomic number is 8, nitrogen atomic number is 7, the oxygen atomic mass is 15, the atomic mass of nitrogen is 14. Now if you consider the different elements having same number of neutrons, so neutrons, how do you determine the neutrons in the oxygen? In this oxygen, number of neutrons is equal to the mass of an element minus the atomic number. So neutrons is equal to mass of an oxygen is 15 minus 8 is equal to what? N is equal to 7. Here also number of neutrons is equal to atomic mass minus atomic number. Number of neutrons is equal to atomic mass is what? 14 minus atomic number is 7, that is number of neutrons is equal to 7. So different elements having same number of neutrons is called as isotones. So dear students, among these three definitions, one will be the compulsory for the point of examination. So 100% one question will be there for your examination with example. What is isotopes? What is isobars with an example? What are isotones? Give an example. So among these three definitions, one definition will be compulsory for the point of examination, 100% question. So please carefully read these questions. Stop. Now let us consider an isoelectronic species. What do you mean by isoelectronic species? Iso means same. Iso means same. What should be same? Electrons should be same. What should be same? Electrons should be same, but different nuclear charge. Then such type of species are called as isoelectronic species anta ಹೇಳ್ತೀವಿ. So how do you define isoelectronic species? So here we can define isoelectronic species are having same number of electrons, but different nuclear charge. Elements or ions are having same electrons but different nuclear charge is called isoelectronic species. Isoelectronic species. For example, how can you give an example for this isoelectronic species? So for example, sodium is an element or ion which is having the 10 electrons but nuclear charge is +1, and magnesium is having +2 charge, the number of electrons is 10 but nuclear charge is +2, and aluminium 3+ is having 10 electrons, nuclear charge is 3+, and neon is having 10 electrons, and fluorine having 10 electrons, so etc. So here the each elements are having same number of electrons but different nuclear charge is called isoelectronic species. The number of electrons in the sodium is 10. Why? Because the atomic number is 11, one electron is lost, that's why that is equal to 10. Here the atomic number is 12, the number of electrons lost is 2, that is equal to 10. Here also the number of electrons is 10. Here the atomic number is 13, the number of electrons lost is 3, that gives 10. The atomic number 13, the total number of electrons present in the aluminum 3 plus is 10. Neon, the atomic number is 10, the number of electrons lost 0, that is equal to 10, that is 10. So here F minus 9 is the atomic number, gained 1 electron, so that's why that becomes 10. So total number of electrons present is 10. So many elements are having same number of electrons but different nuclear charge. See here you are observing different nuclear charge, 0 nuclear charge. So elements having same number of electrons, but different nuclear charge is called isoelectronic species. So this is an example for the isoelectronic species. Elements having same number of electrons but different nuclear charge is called isoelectronic species. Okay, now let us discuss about the electromagnetic radiations. Electromagnetic radiations. So what do you mean by electromagnetic radiations? The wave which consisting of both electrical and magnetic field. Such kinds of waves are called as electromagnetic radiations. So electromagnetic radiations are the radiations which consisting of electric field and also as well as magnetic field. Such kinds of radiations are called as electromagnetic radiations. What are the important electromagnetic radiations? One is wavelength. So what do you mean by wavelength? Define wavelength and write its SI unit. So wavelength andre enu? So wavelength is nothing but any of the wave which can be moving on its propagation. So this is an wave which is moving on a propagated line. This is an perpendicular line. So this is propagating line. Any waves which can move so like this. So this is propagation, this is an wave, this is crest, this is trough. This is crest, this is trough. So the effective distance between the any two consecutive troughs or crests is called as wavelength. So for example, this is an crest, this is an crest. The effective distance between the any two consecutive crests or troughs is called as wavelength. It is the effective distance between the any two consecutive crests or troughs is called wavelength. What do you mean by wavelength? Wavelength, it is the effective distance between the any two crests, consecutive crests or troughs is called wavelength. So idu difference agirbodu athava you can take any two effective distance between these two. The wavelength is represented by lambda. This is called lambda. Lambda is the symbolical representation for the wavelength. The SI unit for the wavelength is it can be measured in terms of meters. It can be measured in terms of angstrom. It can be measured in terms of picometer or nanometer. So this is can be expressed in terms of wavelength, can be expressed in terms of meter or angstrom, picometer, nanometer, etc. So these are the SI unit for the wavelength. Usually we are measuring in terms of meters. Okay. Now let us go for one more important electromagnetic radiation, that is frequency. Stop Manu. Now let us discuss about the second electromagnetic wave, that is frequency. What do you mean by frequency? So frequency is nothing but the number of waves passing through a given point per second. is called frequency. For example, this is an propagation wave. This is an propagating wave. So the number of waves which are passing through a given particular point per second, this is a particular point. I will choose this is a particular point. The number of waves which are passing through a given particular point is called frequency. How many waves? 1, 2, 3. So 3 waves are passed per second means that is nothing but frequency. The number of waves passing through a given point per second. This is very important. Passing through a given point per second is called frequency. So what do you mean by frequency? The number of waves passing through a given point per second is called frequency. This is a given point. So how many number of waves are passing in this point per second? So that is called as frequency. What is the SI unit for the frequency? The SI unit for the frequency is hertz. The SI unit for the frequency is hertz, or per second. Per second is the SI unit for the frequency. The third electromagnetic radiation is wave number. That is wave number. So how do you define the term wave number? It is the reciprocal of wavelength is called wave number. It is the reciprocal of wavelength. Reciprocal of wavelength is called wave number. So what is the reciprocal of wavelength? So reciprocal of wavelength is called wave number. So wave number, so it can be represented as frequency, can be expressed in terms of mu. So wave number is expressed in terms of mu bar. Mu bar is nothing but wave number. Wave number is equal to, it is the reciprocal of wavelength, is called as frequency. The frequency can be expressed in terms of reciprocal of wavelength is called as wave number. So what is the SI unit for the wave number? The SI unit for the wave number is, wave number can be expressed in terms of mu bar, and the SI unit for the wave number is, SI unit is per meter or per centimeter is the SI unit for the wave number. Okay, so these are all the important electromagnetic radiations. So among these definitions, so one will be compulsory for the point of examination. So 100% question. So one will be asked for you for 2 marks. For 2 marks, one question will be asked for you for the point of examination. What is frequency? Write its SI unit. What is wave number? Write its SI unit. So like this, they will ask in the point of examination. So be thorough about these questions. Now let us go for one more important definition, that is block body radiations. Okay, block body radiation. Stop, man. Let us discuss about black body radiation. This is very important for you for the point of examination. It may ask for you 2 marks. Block body radiation. Define the term block body radiation or explain block body radiation. So an ideal body which can absorb or emits all type of frequencies is called black body. The radiations emits from such a body is called block body radiation. So what do you mean by block body radiation? So block body radiation is defined as an ideal body, means that let us consider any one type of ideal body. So ideal body which can absorbs or emits, all type of frequencies. So any type of frequencies it can be absorbs or emits, such type of body is called as black body. Such type of body is called as black body. Black body means it is a black colored layer which can tendency to absorb the sunlight on its surface, or it can emits the radiations from that body, is called such type of frequencies are called as black body anta karitivi. So such bodies which can absorb all type of frequencies or emits all type of frequencies, such kind of ideal body is called as black body. And sometimes the radiations emits from the such a body, sometimes radiations are emits from such a body, then that is called as black body radiation. So radiations are emits from black body, then such radiations are called as black body radiations anta karitivi. So ನೀವು ನೋಡಿರಬಹುದು umbrella which is an covered with a black colored coated layer that can be so absorb the heat or emits the heat. It can absorb all kinds of frequencies and it can emit the all kinds of radiations from that body, that is called as an black body radiation anta karitivi. The body which can emits the radiation, that is called as black body radiations. Okay, thank you.